Cosmos birds is a concept that sits at the intersection of human imagination, ancient symbolism, and modern astrophysical understanding. And to truly understand it, we must begin not in space, but in the human mind itself. Since long before telescopes, humans looked at the sky and interpreted motion, light, and patterns using familiar forms. And among the most powerful of these forms was the bird, a creature that defied gravity, moved freely between earth and sky, and appeared to belong to a realm beyond ordinary human reach. When ancient peoples saw streaks of light crossing the heavens, glowing clouds stretching like wings, or luminous objects diving and rising, they described them using the closest living analogy: birds of fire, birds of light, birds of the gods. Over time, this symbolic language evolved, and today, when we speak of cosmos birds, we're not describing literal biological animals flying in space, but a grand synthesis of metaphor, physics, and cosmic processes that resemble avian behavior in movement, structure, and function in the universe. Scientifically, the universe is full of phenomena that mirror flight, migration, nesting, and signaling, which are core characteristics of birds. Astrophysical jets erupt from black holes like colossal wings extending thousands of light years. Nebulae spread out like feathers illuminated by stellar radiation. Comets dive toward the sun and then escape like celestial swallows. And even galaxies themselves can be seen as vast cosmic creatures moving through the cosmic web. The idea of cosmos birds, therefore, serves as a narrative framework that allows us to explore complex astrophysical concepts in an intuitive yet authentic way without distorting scientific truth. The cosmos is not static. It is dynamic, alive with motion, currents, flows, and cycles, and birds have always represented motion, purpose, and freedom. When plasma streams travel along magnetic field lines, when charged particles spiral and emit radiation, when stellar winds sweep across interstellar space, these are not random actions. They follow laws, patterns, and rhythms, just as birds follow migratory routes shaped by gravity, magnetism, and climate. The universe, too, has its invisible pathways defined by dark matter filaments, gravitational wells, and energy gradients, and cosmos birds can be thought of as the visible expressions of these invisible structures. From a historical perspective, nearly every civilization imagined sky birds. The Egyptian Bennu associated with rebirth and stellar cycles, the Persian simurgh representing cosmic knowledge, the Native American thunderbird embodying storms and cosmic power, and the Garuda of South Asian mythology linked to the sun and celestial travel. These were not naive fantasies, but early attempts to explain natural phenomena like eclipses, comets, auroras, and meteors using symbolic intelligence. Today, science provides us with instruments, equations, and data, but the core wonder remains the same. Cosmos birds is thus not mythology replacing science, but mythology refined by science, a poetic lens through which we can understand real cosmic mechanisms. In the modern astrophysical sense, cosmos birds can be classified into conceptual categories, such as stellar birds representing stars that move through the galaxy, solar birds representing flares, prominences, and coronal mass ejections, galactic birds representing relativistic jets from supermassive black holes, and migratory birds representing cosmic rays, neutrinos, and high-energy particles that travel vast intergalactic distances. These entities are not alive in the biological sense, but they exhibit behaviors analogous to life. They are born, evolve, interact, and die. Supernovae, for example, can be seen as the death cry of a massive stellar bird whose final outburst seeds space with heavy elements, forming the feathers from which future worlds arise. Even the formation of planetary systems resembles nesting behavior, as disks of dust and gas collapse and organize around young stars, creating protected environments for planets to emerge. The authenticity of the cosmos bird's concept lies in its grounding in verified astrophysical processes: gravity, nuclear fusion, electromagnetic radiation, spacetime curvature, and particle physics. Nothing here violates scientific understanding. Instead, it reframes it into a cohesive narrative that can be grasped emotionally as well as intellectually. By seeing the universe as filled with bird-like motion and purpose, we gain a deeper appreciation for its structure, scale, and elegance. In the next part, we will move deeper into the science, exploring how cosmic motion, energy flows, and space-time dynamics give rise to the phenomena that inspired the idea of birds in the cosmos, and how modern astronomy observes and measures these majestic celestial flights. To understand cosmos birds in a scientifically authentic way, we must examine motion, because flight is the defining essence of any bird, and motion is also the defining language of the universe. Nothing in the cosmos is truly at rest. Stars orbit galactic centers, galaxies drift within clusters, stream along dark matter filaments, and even space-time itself expands, carrying everything with it. This universal motion is governed by fundamental forces, primarily gravity, electromagnetism, and the strong and weak nuclear forces, and when these forces interact on vast scales, they produce behaviors that closely resemble flight, soaring, gliding, diving, and migration. Gravity acts as the primary sculptor of cosmic flight. Much like air currents shape the flight of birds on Earth, gravity wells curve space-time and create pathways along which matter and energy travel. Stars orbit within galaxies in flattened, rotating disks, not unlike flocks following invisible wind patterns. Gas clouds collapse and spin, forming spiral arms that resemble sweeping wings. And when galaxies interact, their tidal tails stretch outward like enormous feathers trailing behind a flying creature. These motions are not chaotic. They follow conservation laws, angular momentum, energy minimization, and equilibrium states, which mirror the efficiency seen in biological flight, where birds instinctively choose paths that minimize energy expenditure. Electromagnetic forces add another layer to cosmic flight, particularly in plasma, which makes up more than 99% of visible matter in the universe. Plasma responds to magnetic fields, creating streams, loops, and arcs that move with remarkable elegance. Solar prominences rise and fall along magnetic field lines like luminous wings unfurling and folding. Solar flares erupt suddenly, releasing stored magnetic energy in explosive bursts similar to a powerful wing beat. Coronal mass ejections launch billions of tons of charged particles into space, forming expanding halos that race outward like cosmic birds escaping a stellar nest. On even larger scales, accretion disks around black holes and neutron stars generate relativistic jets, narrow beams of particles accelerated to near light speed that extend far beyond their host galaxies. These jets are among the most striking real-world counterparts to the idea of cosmos birds. They emerge symmetrically from opposite poles of a rotating central object, creating the appearance of colossal wings. These jets are shaped by intense magnetic fields and rotational energy, and they can remain stable for millions of years, traveling distances that dwarf entire galaxies. The precision and persistence of these structures reveal that cosmic flight is not metaphorical whimsy, but a natural outcome of physics under extreme conditions. Another key aspect of avian behavior is migration, and the universe is filled with migratory phenomena. Cosmic rays are high-energy particles accelerated by supernovae, active galactic nuclei, and other violent events. They traverse the galaxy and beyond, crossing magnetic fields and interacting with interstellar matter. Neutrinos, nearly massless particles produced in stellar cores, supernovae, and black hole environments, pass effortlessly through planets, stars, and entire galaxies, carrying information across cosmic distances. These particles are messengers, travelers that link distant regions of the universe, just as migratory birds connect continents on Earth. Their paths are shaped not by instinct but by fundamental laws, yet the result is strikingly similar. Directed, long-range movement across vast environments guided by invisible forces. Even light itself participates in cosmic flight. Photons emitted by stars travel across space, sometimes for billions of years, before being absorbed or detected. Gravitational lensing bends their paths, causing them to arc around massive objects, creating rings and multiple images that resemble flocks distorted by atmospheric currents. The cosmic microwave background radiation, the oldest light in the universe, surrounds us like the echo of an ancient migration, carrying information from the universe when it was only hundreds of thousands of years old. Spacetime curvature adds another dimension to the concept of cosmos birds. In Einstein's general relativity, massive objects warp spacetime, and moving bodies follow geodesics, the straightest possible paths in curved space. This means that what appears as a curved flight path is actually a straight trajectory through a curved geometry. Planets orbit stars, stars orbit galaxies, and galaxies move within clusters not because they're being pulled through space in a classical sense, but because spacetime itself guides their motion. This is analogous to birds gliding along thermal columns, invisible structures that shape their flight without physical contact. Energy flow is another crucial element. Birds require energy to fly, and the universe is defined by energy transfer. Stars convert mass into energy through nuclear fusion, radiating light, heat, and particles. This energy drives stellar winds, influences planetary atmospheres, and powers chemical reactions that eventually lead to life. Supernovae redistribute energy and matter on colossal scales, injecting turbulence into the interstellar medium, triggering new star formation and enriching space with heavy elements. This cycle of energy release and redistribution mirrors ecological energy flows on Earth and reinforces the idea of the universe as a dynamic, interconnected system rather than a static collection of objects. When we speak of cosmos birds soaring through the universe, we are therefore speaking about the natural tendency of matter and energy to organize, move, and interact according to deep physical principles. The bird imagery is not a distraction, but a cognitive bridge. It allows us to visualize magnetic field lines as invisible skies, plasma streams as flapping wings, and gravitational pathways as migratory routes. This perspective does not diminish scientific rigor. Instead, it enhances comprehension by aligning abstract mathematics with intuitive imagery. In the next part, we will explore the birth, life, and death cycles of cosmos birds, examining stellar evolution, galactic activity, and cosmic recycling as stages in a vast avian life cycle written across the universe itself. Every bird on Earth follows a life cycle: birth, growth, maturity, and death. And remarkably, the universe follows the same fundamental rhythm, though on incomprehensibly larger scales. In the framework of cosmos birds, this life cycle is expressed through the formation, evolution, transformation, and dissolution of cosmic structures governed by astrophysical laws. The birth of a cosmos bird begins in the cold, dark regions of interstellar space, where vast molecular clouds drift silently. These clouds, composed mainly of hydrogen, helium, and trace heavier elements, are the cosmic eggs from which stars are born. Under the influence of gravity, small perturbations cause regions of these clouds to collapse, forming dense cores. As collapse continues, temperature and pressure rise until nuclear fusion ignites in the core, giving birth to a star. This moment is analogous to hatching a newborn cosmos bird. Its first light breaks through surrounding dust and gas, creating glowing nebulae that resemble soft, luminous feathers illuminated from within. Protostars often form in clusters, and stellar nurseries can be seen as cosmic nests where many young birds are born together, bound by shared origin and environment. During this early phase, stellar winds and radiation begin to sculpt the surrounding material, carving cavities and pillars in nebulae. These outflows act like the first wing beats, pushing away leftover material and defining the star's future path. As the star enters its main sequence phase, it reaches a state of balance where gravitational collapse is countered by the outward pressure of fusion energy. This long, stable period is the adulthood of a cosmos bird, during which it shines steadily, sometimes for billions of years, converting hydrogen into helium and emitting light across the electromagnetic spectrum. The characteristics of this phase depend primarily on mass. Massive stars burn brighter and faster, living shorter, more intense lives, while smaller stars like red dwarfs live quietly for trillions of years, emitting gentle, steady light. Planetary systems often form during this stage from disks of dust and gas orbiting the young star. These disks flatten and organize due to conservation of angular momentum, giving rise to planets, moons, asteroids, and comets. In the cosmos bird's narrative, these systems can be seen as feathers and ornaments carried by the stellar bird, or even offspring that travel alongside it through the galaxy. The evolution of a cosmos bird becomes more dramatic as it exhausts its core fuel. When hydrogen runs out, fusion shifts to heavier elements, causing the star to expand into a red giant or supergiant. Its outer layers swell and cool, creating immense extended envelopes that can engulf nearby planets. This phase represents aging, a transformation rather than immediate death. For lower mass stars, the final stages involve the gentle shedding of outer layers, forming planetary nebulae, beautiful symmetrical structures glowing in vibrant colors, surrounding a dense white dwarf core. These nebulae resemble luminous shells or molted feathers drifting away, marking the end of active flight. For massive stars, the end is far more violent. When fusion reaches iron, no further energy can be extracted, and the core collapses catastrophically, triggering a supernova explosion. In this moment, the cosmos bird ends its life in a brilliant final cry, releasing more energy in seconds than the sun will emit in its entire lifetime. The explosion propels heavy elements into space. Iron, gold, uranium, and other materials essential for planets and life. These remnants seed future generations of stars, making death not an end, but a transformation. Supernova remnants expand outward, forming complex filamentary structures that truly resemble shattered wings glowing across space. What remains of the core may become a neutron star or black hole. Neutron stars are ultra-dense objects spinning rapidly and emitting beams of radiation that sweep across space like lighthouse signals. These pulsars can be imagined as the still beating heart of a fallen cosmos bird. Black holes, on the other hand, represent an extreme transformation where gravity becomes so intense that not even light can escape. Yet even black holes participate in cosmic flight through their influence on surrounding matter and the powerful jets they can produce. Galaxies themselves undergo life cycles. Spiral galaxies can merge and evolve into elliptical galaxies. Star formation rates rise and fall. Active galactic nuclei ignite and fade. In the cosmos bird's framework, a galaxy can be seen as a colossal flock or even a single vast bird composed of billions of stellar birds bound together by gravity and dark matter. When galaxies collide, their stars rarely collide directly, but gravitational interactions distort their shapes, producing long tidal tails, streams of stars and gas that arc through space like extended wings. These interactions can trigger bursts of star formation, effectively birthing new cosmos birds in the aftermath of collision. Even on the largest scales, the universe itself has a life story, from the hot, dense beginning of the Big Bang to the gradual cooling and expansion over billions of years. Structures formed, evolved, and in some cases faded. This grand temporal arc reinforces the authenticity of viewing cosmic phenomena through life cycle analogies, because the laws of thermodynamics ensure that change, evolution, and eventual transformation are unavoidable features of the cosmos. In the next part, we will explore how observation technology and modern astronomy allow us to witness these life cycles in action, turning the poetic vision of cosmos birds into a scientifically grounded observational reality. The idea of cosmos birds would remain purely philosophical if humanity lacked the ability to observe and verify the cosmic processes that inspire it. But modern astronomy has transformed this vision into an evidence-based exploration of the universe, allowing us to witness celestial motion, birth, transformation, and depth with extraordinary clarity. Observation is the bridge between imagination and authenticity, and every major advancement in astronomy has revealed new layers of cosmic flight. Ancient observers relied on naked-eye astronomy, charting the motions of stars, planets, and comets. And even with limited tools, they noticed wandering stars, sudden appearances, and disappearing lights. These observations laid the foundation for understanding that the sky was dynamic rather than fixed. The invention of the telescope marked the first major leap. Galileo's observations of Jupiter's moons revealed miniature systems in motion, while the phases of Venus demonstrated orbital dynamics. Kepler's laws later quantified planetary motion, showing that celestial bodies follow predictable paths shaped by gravity. These early insights already hinted at structured cosmic flight governed by mathematical order. In the modern era, observation extends far beyond visible light. The universe emits information across the entire electromagnetic spectrum, from radio waves to gamma rays, and each wavelength reveals a different aspect of cosmos birds. Radio astronomy allows us to map cold gas clouds, the nurseries where stellar birds are born. Infrared observations penetrate dust, revealing protostars forming within molecular clouds. Optical telescopes capture the steady glow of stars and the intricate shapes of nebulae. Ultraviolet instruments highlight hot, energetic regions around young stars and massive stellar winds. X-ray observatories detect extreme environments such as neutron stars, supernova remnants, and accretion disks around black holes, while gamma-ray telescopes trace the most energetic events, including relativistic jets and cosmic explosions. Together, these observations form a multi-layered portrait of cosmic flight. Space-based observatories have been particularly transformative. Freed from atmospheric distortion, telescopes like the Hubble Space Telescope have revealed structures with breathtaking clarity. Pillars of gas shaped by radiation, bow shocks formed by stars moving through interstellar material, and planetary nebulae with symmetrical patterns resembling wings and eyes. These images are not artistic exaggerations, but direct evidence of physical processes shaping matter in motion. More recently, the James Webb Space Telescope has extended our vision deeper into dust-shrouded regions, revealing unprecedented detail in star-forming areas and early galaxies, showing us cosmos birds at stages previously hidden from view. Webb's infrared sensitivity allows us to observe the faint heat signatures of young stars and the composition of exoplanet atmospheres, further expanding the scope of cosmic life cycles. Ground-based observatories also play a crucial role. Large optical telescopes equipped with adaptive optics correct for atmospheric turbulence, achieving near-space quality resolution. Radio arrays like the Atacama Large Millimeter Array map cold gas dynamics with exquisite precision, while gravitational wave detectors, such as LIGO and Virgo, have opened an entirely new observational window, detecting ripples in spacetime produced by colliding black holes and neutron stars. These events represent some of the most dramatic cosmic flights imaginable. Massive objects spiraling toward each other, accelerating and merging, releasing vast energy in gravitational waves that travel across the universe, carrying information about extreme motion through space-time. Particle observatories add another dimension. Neutrino detectors buried deep in ice or water capture elusive particles arriving from distant cosmic events, confirming that energetic processes like supernovae and active galactic nuclei send messengers across intergalactic space. Cosmic ray observatories track high-energy particles striking Earth, revealing acceleration mechanisms tied to shock waves and magnetic fields. These detections reinforce the idea of migration and long-distance travel central to the cosmos bird's framework. Even computational astronomy contributes by simulating cosmic evolution using supercomputers. These simulations model galaxy formation, star cluster dynamics, and plasma behavior under realistic physical conditions, producing visualizations that often resemble flocks, streams, and wings of matter moving through space. Simulations allow scientists to test theories, compare with observations, and predict future behavior, ensuring that our understanding remains grounded in physics rather than metaphor alone. Observation also teaches humility, because cosmic timescales far exceed human lifetimes. Astronomers often infer motion by comparing snapshots across decades, centuries, or through statistical populations rather than watching events unfold in real time. Yet even this limitation highlights the continuity of cosmic flight. The universe has been moving long before we observed it, and will continue long after. The concept of cosmos birds therefore gains strength from the fact that every new instrument reveals additional evidence of structured motion, energy flow, and life cycle behavior in the cosmos. What once appeared as static points of light are now understood as dynamic participants in a vast interconnected system. In the next part, we will move beyond observation into meaning, exploring why the cosmos bird's perspective matters for human understanding, philosophy, education, and our place within the universe. Beyond physics, observation, and data, the concept of cosmos birds holds profound significance for human understanding, because science is not only about measurement, but also about meaning. Humans seek narratives that connect knowledge to identity and purpose, and throughout history, cosmic imagery has shaped philosophy, culture, and self-perception. Cosmos birds provide a framework that unites scientific accuracy with symbolic depth, allowing humanity to comprehend its place in an immense and often overwhelming universe. The bird has always symbolized transcendence, freedom, and connection between realms, earth and sky, body and spirit, matter and motion. When this symbol is extended to the cosmos, it becomes a bridge between the finite human experience and infinite cosmic scale, reminding us that we are not separate from the universe, but expressions of it in motion. One of the most powerful implications of cosmos birds is the realization that humanity itself is composed of cosmic material forged in stellar depths. The elements in our bodies, carbon, oxygen, nitrogen, iron, were created in the cores of stars and distributed through supernova explosions, meaning that every human being is literally made from the remnants of ancient cosmos birds. This is not metaphorical poetry, but scientific fact, and it fundamentally alters how we understand existence. Life on Earth is not an isolated accident, but part of a continuous cosmic process extending back billions of years. When we observe stellar birth and death, we are witnessing our own deep ancestry. The universe is not merely a backdrop for life, but its source and sustainer. This perspective fosters a sense of belonging rather than insignificance. The scale of a universe can easily make humanity feel small and irrelevant, but cosmos birds reframe scale as participation rather than exclusion. Just as a single bird is small compared to the sky, yet fully part of it, a human life is brief compared to cosmic time, yet fully embedded in cosmic evolution. Our planet orbits a star, our star orbits a galaxy, and our galaxy moves within a larger cosmic structure. Every breath we take, every atom we exchange, connects us to cosmic flows. The idea of flight emphasizes this continuity. Motion is not something that happens to us. It is something we are part of. Philosophically, cosmos birds resonates with process-based views of reality, which emphasize becoming rather than static being. The universe is not a collection of fixed objects, but an unfolding story of interactions, transformations, and movements. Stars form, evolve, and die. Galaxies merge and reshape. Spacetime itself expands. This aligns with modern physics and challenges outdated mechanistic views of a clockwork universe. Instead, we see a cosmos that is dynamic, creative, and relational. The bird imagery captures this process-driven nature intuitively, making complex scientific ideas accessible without sacrificing rigor. In education, cosmos birds can serve as a powerful pedagogical tool. Abstract concepts like magnetic fields, plasma dynamics, stellar evolution, and space-time curvature are difficult to visualize, but when framed as flight, migration, nesting, and transformation, they become more intuitive, especially for learners encountering astrophysics for the first time. This does not mean replacing equations or data, but supplementing them with conceptual models that engage imagination alongside intellect. Historically, many great scientists, including Einstein, Feynman, and Faraday, relied heavily on visual and metaphorical thinking to develop their theories. Cosmos Birds continues this tradition by providing a structured, imaginative lens grounded in evidence. The symbolic dimension also extends to ethics and responsibility. If we understand ourselves as part of a cosmic ecosystem rather than masters of a separate world, our relationship with Earth may change. Environmental destruction becomes not merely a local problem, but a disruption of a rare and precious outcome of cosmic evolution. Earth can be seen as a delicate nest formed through billions of years of cosmic processes. Protecting and sustaining life in this view becomes an act of cosmic stewardship, recognizing that the universe has invested immense time and energy into creating conditions for consciousness to arise. The search for extraterrestrial life also gains new context. If life exists elsewhere, it too would be composed of the ashes of stars, following similar physical laws, different expressions of the same cosmic flight pattern. Communication with such life would not be contact between strangers, but between distant relatives shaped by the same universal processes. Even the act of space exploration reflects the Cosmos Birds narrative. Humanity building spacecraft, probes, and telescopes is an extension of cosmic curiosity, matter becoming aware of itself and seeking to understand its origins. When spacecraft leave Earth, they are not escaping the universe, but participating more consciously in its motion. Our probes are like fledgling birds leaving the nest, guided by mathematics, physics, and curiosity. Finally, Cosmos Birds offers emotional resonance in an era often dominated by data abstraction and technological mediation. It restores a sense of wonder without abandoning truth. The universe revealed by science is not cold or meaningless. It is rich with structure, rhythm, and beauty. The image of cosmic flight captures this elegance, reminding us that knowledge and awe are not opposites, but partners. As we continue to explore the cosmos through observation, theory, and imagination, the Cosmos Bird's perspective invites us to see the universe not as a distant machine, but as a living, unfolding journey of motion, energy, and transformation. In the next and final part, we will integrate all these dimensions into a unified conclusion, reflecting on the future of cosmic understanding and humanity's evolving relationship with the universe. As we conclude the exploration of Cosmos Birds, we arrive at a unified understanding that blends science, imagination, observation, and meaning into a single coherent vision of the universe. Cosmos Birds is not a claim about literal creatures inhabiting space, but a disciplined way of seeing, a language that translates the deep truths of astrophysics into an intuitive narrative of motion, life cycles, and connection across scales, from subatomic particles to galactic superstructures. The universe reveals itself as a vast arena of flight, where matter and energy are constantly moving, organizing, transforming, and redistributing according to fundamental laws. Gravity, electromagnetism, nuclear forces, and spacetime curvature act as the invisible skies, winds, and pathways guiding this eternal migration. Stars are born, shine, and die. Galaxies interact and evolve. Particles traverse unimaginable distances, carrying information and influence. And through it all, the universe maintains a dynamic coherence that is both mathematically precise and visually poetic. The Cosmos Bird's framework endures because it remains authentic. It does not invent new physics or distort established knowledge. Instead, it highlights patterns that already exist, patterns of flow, balance, transformation, and emergence. It reminds us that complexity does not negate elegance, and that rigor does not exclude beauty. Modern science increasingly supports this view as we uncover deeper, unifying principles connecting forces, particles, and cosmic structures. The same equations that describe plasma behavior in laboratory experiments govern solar flares and galactic jets. The same gravitational principles that shape planetary orbits influence the formation of large-scale cosmic filaments. This unity reinforces the idea that the universe operates as an integrated system rather than a collection of isolated events. Looking ahead, the future of astronomy and physics promises to reveal even more about cosmic flight. Next-generation telescopes, gravitational wave observatories, neutrino detectors, and space missions will extend our perception further back in time and deeper into extreme environments. We may soon observe the first generation of stars, witness black hole mergers across cosmic history, and map dark matter with greater precision. Each discovery will add new detail to the ongoing story of cosmos birds, revealing new forms of motion and transformation that continue to mirror the ancient intuition that the sky is alive with purpose and movement. Humanity's role in this story is also evolving. We're no longer passive observers confined to a single planet. Our technology allows us to listen to the universe across multiple channels and ascend our instruments far beyond Earth. This capacity carries responsibility as well as opportunity. Understanding ourselves as part of cosmic processes encourages humility, cooperation, and long-term thinking. The same universe that produces stars and galaxies also produced us, and our actions now influence the only known world where cosmic matter has become self-aware. Protecting this world, advancing knowledge responsibly, and fostering curiosity become acts aligned with cosmic evolution rather than opposed to it. Ultimately, Cosmos Birds offers a perspective of belonging. It tells us that motion is fundamental, change is inevitable, and connection is universal. We are not strangers in a cold universe, but participants in a vast, unfolding journey written in light, gravity, and time. When we look up at the night sky and see stars moving slowly across the heavens, or imagine galaxies drifting through the cosmic web, we are witnessing the ongoing flight of the universe itself, and within that immense flight, our own lives, brief yet meaningful, trace their own paths like small but conscious birds navigating the infinite sky.